We're live. Prepare
Oh
to
no.
log in the meeting.
How you doing, Mike? Wait, are we live right now?
It's setting up your meeting for YouTube Live. It's doing something. Bang, bang, boom. Yes, it's live now, yeah.
Okay, as soon as you chuck that link into Slack, I can tweet it for our fans.
Yeah. Those fans, yeah. Right, bam, there we go.
All right, here is the link. I have to get a little better at this, I think.
Yeah, the other day what I did was I started the meeting first, then you can put in a code from Zoom, but I did it the wrong way around this time, so it'll be better next time. But you know, bear with. So Mia, are you going to do pretend Eric and say hello to the to the masses, or are we going to wait 10 minutes? We just like chat. Oh look, Stathis is in there. Michael is in there. We've already got 2 knocking on the pub door, so that's good.
So I just retweeted it with the link. So I'm going to although I guess our subscribers probably see it, right?
Yeah, we're live now, right?
We're
people already watching.
Live. We've
they're seeing the sausage being made here.
Oh no.
Well, hopefully it's nice and clear, everyone. Yeah.
They're gonna think we don't know what we're doing.
Oh, well. There you go.
All right.
The truth will out.
Hello and welcome to Apropos. Today we have our panel of Ray.
Hello.
Mike.
Hello.
And Mia. Hi, and I am Eric. We are a Clojure program where you can listen and chat live in the chat box. So let's begin. What have you got for us today, Mike, Mia, and Ray?
Can I just check, by the way, are we actually a Clojure program? Because that's quite an impressive Clojure program.
It's got AI.
You know, I mean,
it's
advanced compilation going on here.
Yeah.
Right. Anyway, yeah. Probably Mike was going to start us off with something to do with this Clojure script.
Oh yeah, I could start on that. Yeah. So I guess it's been a long time, right, since we've had a Clojure script release. It's going on a year, maybe. But anyway, so we're gearing up to have another release, and to be honest, it's hard for me to remember all the features that are in it, but there is one cool big one that's going to be in it, which is there is new analysis capability for Clojure libraries. So what that means is if you're in the REPL and you're doing things like you do dir to see the functions that are in a namespace, or you do doc to get the doc string for a given function, all that stuff's driven by analysis metadata that's in the compiler. And essentially what we're going to get with this new release is that very same stuff for Clojure libraries. So what that means is, like, if you use the Google Clojure library or any library, I don't think it's specific to Google Clojure library, then you will get these features, which I think is great, because a lot of times, if you want to use something from Google Clojure library, you end up having to go look up those functions online to see what they are, or read their documentation online. So now you'll just have all that right in the REPL. And furthermore, one cool thing that you get now is the types are kind of gleaned from that as well. So it's more than just like a usability thing. It could lead to performance improvements, because it will know the types of return values of functions, and perhaps even the types of inbound functions. If I remember correctly, we might know that as well. It's been a while since I've looked at this feature, and that could lead to, if the ultimate dream there is that the compiler could effectively perhaps use that to help catch silly errors, when you're passing in a number where a string was expected and stuff like that. So types would be part of this whole story too. the big picture is it's that feature is so new. We kind of would like people to try it. It's on master now. It's been there for quite a while. And it's easy to actually try master of ClojureScript. You just kind of put in the SHA and use it as a git lib, rather than, you don't have to actually wait for a formal jar of ClojureScript to be released to try the thing. You can actually just put in the, git URL and the :SHA, and then you'll be using that version of ClojureScript directly from GitHub. I thought I could actually just show this stuff rather than trying to explain it verbally.
Demo.
Yeah.
Yay!
Demo.
Because it's all these ideas are abstract, and it's better just to show it, right? Let's see. So,
Me, I'm always in favor of types. So.
Oh
my
okay.
God.
You can have your types and eat them too. Let's see.
Oh, good, because I
let's
get
see.
lunch.
So I'm going to try to share a terminal. Let's see. Okay, now I'm sharing a terminal. I don't know if you can see this one.
Wow, Zoom.
Can you see?
Zoom just works.
Is it working for you? Yeah.
Yeah, it's working.
Okay. So let's see. We can go through some of these features. So if you, what I'm talking about is if you require something like, right? If you want something that's in there in the Google string namespace, you can do that. And then what you would do at this point is you would actually just somehow out of band know the functions that are available in there by looking online. But what you can now do is things like this. And you can see all the functions that are in there. So let's pick one. So they're all, quite a few, but let's pick maybe trim. Maybe there's a left pad in there somewhere. So you can get doc on these things now. And it's basically, these are the things that are down in, the annotations and the doc string effectively that's down inside the Google Clojure library. So it's showing that to you. So now you can, of course, you can call it like you could before. And would take the spaces off, right? But that's not new. You've been able to do that before. And then I want to prove to you that it has types. So I have the ilk stuff that I wrote in there. And the way ilk works, you can, it's a macro that basically will tell you the type of the expression that you give to it. So this will say, hey, it's a number. So if we do the same thing with this previous thing, this will prove to you that types are being inferred. Whoops, wrong one. Let me grab the other one. That's basically saying that that this string function or trim function returns a string type. So that means if you're using Google Clojure functions directly, or any Clojure library functions directly, then your program would perhaps benefit from any type analysis that can be done based on those return types coming out. And there's things like if you look in the Clojure string library. Right from my keyboard, I got the mechanical thing going.
People love that, mate. Don't worry about it.
I enjoy it, yeah. So, okay, so there's a trim in there as well. So if we do string trim, the actual one that ships at the library, you can see that it delegates to G-string trim, right?
Interesting.
So in fact, you wouldn't need to use the Google Clojure's function. You could use the ClojureScript level one and have a portable trim. But the thing I wanted to point out is there's this little annotation that we have on there right now, and in the source, in the in the libraries that ship with the compiler, this annotation is sitting there. But in theory, it could be removed and just inferred because the compiler will now see this expression down here, and it will know that it returns a string, and therefore the trim function also returns a string, and this will kind of propagate outwards.
And can I complain?
No. keep your opinions to yourself,
please.
You European.
Oh.
Now I brought it out. Yeah. How could you possibly complain?
Look him.
Please complain. Complain.
No, the only it just so happens that I got bit in the ass by something today, which is very similar to what's going on here. Is that in Clojure script? I don't know if you notice this, Mia, but he has defen type hint trim, which is the return value for trim, apparently. But that's not Clojure.
Enclosure.
If you go into Clojure, you say defen trim, removes the white space, then you say string S. So it's like that. You do it the other way around. And and I must have been blinded by Clojure and Clojure script. By Clojure script. I saw this stuff in Clojure and it kind of passes. That's the weird thing, actually. Look
so
at
in
this.
here, it's actually on the left.
Yeah, got that.
So, but Ray,
That
you
is-
are right. It
that's
does go
weird,
over here.
though.
I think it can go in both places. And
Yeah, but it doesn't always. I think if it's
Yeah.
a primitive, maybe not.
I
No,
don't
it's not
know.
true, even. But I had a problem with bytes, for example. Look at this. This is very interesting, actually. I mean, this is completely sidelining your comment, but if I wanted to put bytes there, if I put bytes where the string is now instead, then it gave me some errors saying it can't find Clojure core typed bytes. But if I put bytes to the left of char sequence S, to the left of that vector, then it passes, it works.
That's where I expect it to be, is before the argument list.
Yeah.
Enclosure. This surprises me that it's there.
Yeah.
Well, that must just
It's a
be
barely
some
used
kind
function. Who cares? You know.
It's got to
But
be some kind of compiler optimization.
But maybe have a look at the core functions, actually, Mike, because this is a string library. So maybe have a look at map or something. Not map.
Okay.
What would be something that returns a type in standard Clojure?
Predicate, maybe. Let's see, what would you want that would return a type? Seems like a lot of them are pretty generic, right?
Yeah, that's right. It's
Reverse, maybe?
Okay.
Reverse should be able to return a collection, I think. But
Yeah,
that's
it's
true.
just a pretty generic one. Yeah.
what's range?
Yeah, range would return a number.
Set, yeah.
And maybe it doesn't matter.
Stefan suggests subs. SUBS.
Oh, subs. That's a good one.
Yeah, it's a good one.
Yeah.
Yeah, that's a strings function sitting in there. There you go. These look better. They're sitting right in front of there.
Yeah.
Okay, yeah.
Yeah.
Weird.
And yeah, so it's annoying because that'll catch you off guard and you won't have a type hint, right? If you don't put it in the right place.
Yeah. Anyway, back to your Clojure scripting, Mike. It was one of those things which bit me, and I sort of forgotten this thing, and
It'll bite you again later too.
Yeah, I'm sure it will.
It's not going away.
Yeah. Especially if you're European, I think it's something to do with the time zone.
Yeah.
We're always
What else?
behind. No, we're ahead of Americans. Or are we behind? I don't know. We're catching up this week.
I'm trying to think if there's anything else in this feature. There's, the analysis metadata gives you essentially dir and, maybe apropos. Would that work? I don't use this function often enough, even though it's the name of our podcast. Apropos trim. Okay. Hey, look. Goog string trim left showed up in there now. Huh. I don't think that would work previously. So that's another example. It's just like, the point is that it's not specifically changing dir nor doc. It's actually bona fide analysis metadata that's being incorporated in for Clojure libraries, so that anything, all the existing tooling that works off that analysis metadata will now work properly, hopefully. And that's what we want to do, is we want people to just try it out, because there's, it's a pretty big feature. It's been there for a few months now, I want to say. So it's been soaking for a while, but yeah, you never know. Like when you go and release a version of the compiler, invariably there's some code base out there that'll have something that'll be affected by it. Yeah. So the only way to find out is to have people try it.
Nice.
Yeah, I think that's roughly the feature.
So is this a kind of like essentially a kind of what should we say, like a enabling feature, Mike?
Yeah, so far, so far I've used it. Whenever I've used it, it's been for these kind of things where I'm just curious. I like if you use Google Crypt, right?
Yeah.
And you're like, what is in there, right? It's that exact thing. Do this, right? And then you're like, and you can do things, right? Hex to byte array to hex. You can just start using these things, and that's very enabling for me, and any of us, right? You're writing the REPL and trying to explore, trying to find a function to use that would perhaps meet some need you have. It's much better if it's just directly there in the REPL for you. Otherwise, you have to go and like hunt online for these namespaces and see what they are.
And the documentation might not exactly be the version of the library that you're looking at and stuff like that.
Exactly. Yeah. It could be like out of sync.
This is fair. Anything that helps. I think it helps you not have to break out of your REPL flow is really nice. So.
So that who knows when this compiler version will be released, but it's been a while, right? It's due.
Just slap a beta on it and throw it out now.
Yeah. That's probably what'll happen in the end, to be honest. Just gonna have to throw it out.
Why don't you just slap an alpha on it and then it will be out there forever?
Yeah. For 2 or 3 years at least.
Meow.
And then you can make a new Clojure script.
Yeah.
Oh, that's exciting. Thank you, Mike.
Oh yeah. There are other features in this release too. I wish they have evaporated from my mind. It's been so long since we've been working on this version.
We got NP exception says, as far as I know, type hints on a symbol is a type hint for the var, whereas a type hint on the argument vector is for the return type of the function. So
it's true, but
it was interesting to see that type hint on the symbol there. It's not something that you see generally.
Yeah, one difference too between Clojure and Clojure script with type hints is that at least for things that aren't like long and double primitives, for all the reference types essentially in Clojure, type hints tend to be things that can help avoid reflection. They can help performance, but if you type hint something incorrectly, I want to say that your program won't break, right? It just won't take advantage of that nice, fast, reflective path.
Do the type hint.
Yeah. But in Clojure script, a type hint is actually the compiler takes your word for it. So if you type hint something, the compiler is going to use that as the truth, and it will use that to actually generate code that could potentially be incorrect if your type hint is actually not correct for the way your code's being used. How
very JavaScript.
Yeah, I mean it's there to make pain for you, right? That's its whole point.
Well, no, it trusts you.
It trusts you.
It doesn't trust itself.
Yeah.
So it's got to trust you. Oh.
Yeah. So I'm slightly confused there, Mike, because I think if you get, like I said, if you get these hints wrong, if you put them in the wrong place and the wrong type, you actually get compile errors.
Oh, Enclosure?
Yeah.
Oh, okay.
So.
Well, I mean, but where is, like, do you mean just like extremely wrong, like just throwing it somewhere where it, or do you mean if you do a type hint for a var and it's the wrong type?
Oh, no, well, I mean...
Okay, let's try it. Let's share the screen.
Like if I just like throw in a caret string into my function somewhere, that it doesn't, I would expect a compiler error, but...
Okay, no, I'm going to share my terminal again and go back into Clojure instead of guessing. Can you see my terminal?
Yeah, perfectly, yeah.
Right, and we'll just make it return X. So it's not going to break, right?
But what type is that one?
One is a number.
Okay, so it is still,
So,
yeah.
So,
but obviously, if you try and do a trim on it or something, it's going to blow up.
Oh, right. Yeah.
It doesn't. If you try and get bytes on it or something like that.
Okay.
But what if we put that type hint on the var?
Oh, yeah. On foo itself. That may be telling you. So I think it may be. Honestly, I don't know. I don't want to speculate, but
so if that is for the return type, right? Then we should. So if we try putting it on the var, then we should maybe see it yell at us if it's the wrong return type. So it would be fine taking in that one, but maybe it would yell at us. Oh, didn't like that. Oh, you forgot foo.
Thank you. Okay, so
okay. Now we try foo. Okay, so it just doesn't really.
It doesn't care. No.
Doesn't care.
I don't know. Yeah. There is a difference though if Enclosure, if you do this, I think this will mean something else. Yeah.
Oh.
So the Chas Emmerich's book has a little small section on this concept, and basically the way he describes it is for the primitive long and double types. If you do that, it's no longer really a type hint. He calls it a type declaration, and what it's doing is it's really generating code that's going to take advantage of those primitive types.
But it's just for how many? It's just for the long.
So for example, if I change this to capital D,
then we won't have a problem.
Right. Exactly. Okay. Yeah.
I actually don't know how many primitive types there are in Clojure.
Well, for this thing that I just mentioned, it only applies to double and long.
Yeah. It would just be for double and long.
Yeah.
Okay.
So in that sense, when Clojure's doing that, it behaves. That's the kind of roughly what you get out of Clojure script.
Yeah.
Where it's actually using that hint to generate more optimal code, and that code is optimized in a way that could break, if you pass in something that doesn't work with that generated code. Yeah.
So never optimize your code.
Yeah, I mean it's
type hinting is horrible, basically.
Yeah. So the theme is like
the lesson of this podcast.
Yeah, you shouldn't. I mean, and it's like especially like Enclosure script. The story there is as inference gets better, then the compiler will figure it all out for you where it can, right? If you need to, you only type hint in like really tight loops where it even matters, right? Same thing's true, I guess, in Clojure. Like you tend not to type hint unless you have like something that's really slow because of reflection or something like that, or yeah. Because it's just not, life is short. It's not worth it. Computers are fast.
Yeah.
That's my opinion.
But my point was that if I put bytes,
okay,
type hint bytes.
Okay, definitely. Is it like this?
You can make a string from bytes, obviously. So it returns bytes, yeah.
Okay.
And let's say if you let's say base 64, decode something like that. If you
base 64.
Yeah, if you go like in this you can do an arrow. Yeah, I'll drive you from here arrow, and you can say like base 64 uppercase base 64. Oh well, yeah. Slash get decoder.
Okay.
I think that will get you a decoder. Then you can say decode. And then you can say, but that will get you the bytes. Yeah. So if it returns bytes, it will all work out very nicely.
Are you just looking for a function that will return some bytes?
Yeah. So you have to.
So we might be able to.
You have to put in X at the beginning, I guess. Okay.
Can we use this maybe just as a thing to, like,
Oh yeah, sure. Yeah.
Okay, I'm just trying to think of something. So
Even
def
simpler.
and-
Yeah, for sure.
Okay. Yeah, because I don't know the base 64 stuff.
Oh yeah. Don't worry about it. Yeah.
Okay, so like this, right?
Yeah.
Okay. Oh, I forgot the function name. See? All right. So now we have that guy there.
And now if you make another function that calls that guy.
Okay. Like this, maybe?
Yeah.
Okay.
And then if you call bar on X, what happens? It was giving me a compile error. Maybe it's across different namespaces. I don't know.
Oh, okay. Interesting.
Huh.
Yeah, maybe you just hit a weird case. I don't know.
Yeah.
Because
It's suggested that if we try defining in the comments here, if we try using a type hint on the var name and then call a function that uses that var, we'll get two different errors if we have one that type hints and one that doesn't. Which I think was what was supposed to be demonstrated here, sort of. But
Yeah, that would be good.
it's just work done. So we could try the string version. So if you do a type hinted string foo1 x.
oh, if I get it wrong, like that?
Yeah, and then,
Okay.
oh, well, this one was suggesting that we do a trim on it just to see what would happen. But
Something like that, maybe.
oh, that's a weird one.
Well, that's just a runtime thing because foo does return
Yeah.
a byte array.
Yeah. So if you actually
Yeah.
read the comment here, I'm sort of switching tracks completely so that
Okay.
we can look at the two different errors that we would see with or without type hinting.
All right. So you've got one foo and foo1 basically.
Right.
So
Yeah. So you've got foo and foo1, and foo is type hinted string, and foo1 is not type hinted string.
Okay.
Then if you call .trim on the result of that function, you should see two different errors depending on whether you've type hinted it.
This is
That and
getting
then
lots of calls out from the chat room today, which is really good.
there's
Yeah.
foo,
Keep it coming.
Yeah. Hello, everyone.
and then foo1 that's not type hinted.
I still think we're still going to get errors because we're doing get bytes x instead of just x. Like I think that we actually want to just
Oh, just
X.
return X. I got you. Yeah. Okay.
Yeah.
Yes. All right.
there we go. So we got one type hinted. We're gonna one
One unhinted.
not type hinted. We're gonna call .trim on each.
Oh. Dot trim. Yes. Or dot get bytes maybe even. Is there a trim? Yeah. Okay. So there's a trim in
Yeah.
that. So then if we do,
And then it says don't call the function, but use the var as the argument. This would be
Right.
trim dot space foo in your current case. Oh, very exciting. I'm actually, I think that it just wants the var, not the. So you're not actually calling the
like
function.
this?
Yeah, but it's gonna be trim dot foo
Trim dot foo. What's dot foo?
or trim dot, right? Because you're calling that method there.
Oh right. Okay.
Yeah.
Oh, you're calling it on the response. Okay.
We're doing a Clojure does Java does Clojure.
Oh my god.
Okay, so we're gonna do trim dot space foo, and then trim dot space foo1. And we
Trim
should see
dot space
different
foo.
errors is
Like-
what we've been promised. Different errors.
Like what I just typed in there? Trim
Uh-huh.
dot space foo.
Yep. So we're gonna see an error
Because it's
there.
trying to do it on the object. Okay. Oh, why? Isn't that a constructor
confused.
trim dot?
I'm
Yeah.
I
confused.
don't think.
Yeah, I don't know. I'm just going based on the chat right now. So
Yeah, but I could buy that basically a type hint would inform the compiler in a way that would change its error messages.
Yeah, let's try it. If we do trim.foo, but foo is the one that is type hinted, so we should expect it to be able to resolve that class name based on the type hint of string, right?
Mm-hmm.
And we don't.
Maybe if I put in.
Oh, .trim was correct.
Yeah. Okay.
Okay, so let's try .trim foo.
Okay. This is
try
fine,
.trim
actually.
foo and then
They do
.trim
get
foo.
different error messages.
Here, it's been proven. You get it. Okay. Yeah.
But I think that what he's trying to say is the .trim. Well, maybe not.
No, what's happening is that it's getting cast back to a string. Then you're getting an error.
Yeah.
But in the first case, it's not getting cast back. It's just flowing through as a long.
Yeah.
Because there's no type hinting.
I think that first one is. This one's reflecting.
No, there it is.
See, it's a reflection warning coming up there.
Yep.
But it's the other one. No reflection warning will be there, but it'll just go for it, right?
Yeah.
And just okay, that makes sense.
All right. Well, who knew we could spend 20 minutes on that?
It's just Java splunking.
Interop is fun, isn't it? You know. But I think the funny thing about it is, in the end, I mean, it's kind of like one of these weird things that, I mean, maybe it's just to stay away from this for 1 second, is that it's kind of like, how do you feel about this? Because on the one hand, I kind of like, you know, I know that interop is a reality when you're looking at Clojure and ClojureScript because you're always sitting on top of VMs. But on the other hand, you want to try and avoid it if you can. So this kind of like type hinting and thinking about the underlying types of the virtual machine are sort of inconveniences and annoyances often, in my opinion. What do you guys think?
So in Clojure, it feels to me that the only time I've ever really felt compelled to type hint was to avoid reflection.
Yeah.
For performance reasons.
Yeah.
Yeah, because it's dog slow, right? Reflection is really, really slow. It's slower than you would expect. By like an order of magnitude beyond what you would expect.
And you want to try to, you know, you're trying to kind of avoid, right? The great promise that Clojure uses to lure a lot of developers over is like, you can write everything that you would use Java for, but in Clojure. And, you know, you don't really, like type hinting sort of feels like you're doing a little bit more interop. Type hinting doesn't feel like native Clojure. It feels a little bit more like native Java. So you really, I don't know, I only use it for reflection warnings. I don't really use it for like the kind of documentation purposes.
Oh, right. Yeah.
Which I think is the other thing people like to use type hinting for.
Yeah. I don't know if I like that, to be honest.
No.
Yeah,
sometimes that's cool, but
it's not really.
Otherwise, it's not a type.
Not what I was promised.
Yeah. But don't you think it's kind of interesting how it plays with like schema and spec and stuff like that? Because that's, you know, I think those two things are, well, let's say spec, because, you know, I don't know if it's going to be called schema or spec 2 or whatever it's going to be called. This new way of like looking at like data that you're getting passed. I mean, essentially those things will give you the types, you know, so that seems to be more of a Clojure way, if you like, of documenting what you're meant to receive. And, you know, if you're getting things from the outside world sort of thing, you know, if it's all inside of your own namespace, then who needs the documentation? But if you're getting things from the outside world, then type hints seem like a fairly weak source, actually, because we've just seen there that they don't enforce very much.
That's one thing. The thing that you just said is one thing that I recall David Nolan mentioning that he would like to add to the ClojureScript compiler, which specifically is if you go through the trouble of writing a spec for a function and you give the arguments specs And those specs are simple enough where you can like, you're using like the string predicate or the, int predicate, then the types, and they're, you're using predicates that let you deduce quickly that certain JavaScript primitive values are being passed to those functions. In those cases, you could leverage those specs to effectively act like type hints, and effectively just generate more optimal code based on the fact that spec is there.
I think I'm lost though. What's the difference between that and a type hint in ClojureScript?
So the thing that David was proposing doing, let's say you write a function. Let's see, or maybe ask your question again. Maybe I'm thinking about it incorrect.
Okay, so It sounds like based on what we just went over on how type hints work in ClojureScript versus how they work in Clojure.
Yeah.
It sounds like there is sort of that inference and optimization that's happening using the type hint in ClojureScript.
Yes.
So I want to know what the value add would be of using this kind of spec version of it.
Yeah, let me even share the REPL and give a demo of where I think that could go. Share.
Demo again.
Demo.
So this is specifically, we'll go back into ClojureScript. All right, let's let this guy fire up again. Can you see my REPL?
Yes.
Yeah.
Okay, so I'll give
I love Zoom.
It just works.
So, oh man, this is so much better. I hope you guys like it. Yeah, we're loving it.
Okay, we'll just start off with this simple example.
Okay.
And I'm going to set it so that we can see the JavaScript that gets generated for a function.
Oh, cool.
So if I then now evaluate foo, I'll see what got generated for foo, right?
Oh, this is a neat trick.
Yeah, it used to be the case that you would see JavaScript all the time when you were using the ClojureScript REPL. It would just kind of be in your face, but it's been kind of tucked away now. And this little var here will kind of revert to some older behavior where if you evaluate a function, you'll see its body. So the point of doing this was to show you this little thing that's sitting inside of here. This is a little bit of code that will take, it'll take any value and kind of turn it into what JavaScript needs in terms of truth. So in particular, an example of that is
empty string or something.
Exactly. So that's true, but it's not true according to JavaScript or 0. So we know all these things are true in Clojure, in ClojureScript semantics. So we have to have this little thing in here, right? Because we don't know that this thing is, well, we don't know the type. We don't know the type of X. So we have to kind of inject this little checked thing, right? And it turns it into like a checked if. But if we instead type hint it, this is just a small example. Now, if we say foo is actually taking a Boolean value directly, if we look at the code that gets generated for that,
you don't have to refer back to that core.truth anymore.
Yeah, and it becomes an unchecked if now, which is slightly faster, right? It's removed this little bit of code. So the way that this can, going back to the thing I was saying earlier, is now the ClojureScript compiler believes you. It's taking your word for this, that this is a Boolean. So now if you do foo of 0, 0 is a truthy value. So it should return 1, right? If we get rid of that type hint, go back to the way the function was before, we'll get the right answer. But by type hinting it, we've promised that X is going to be a Boolean, right? By doing that, we've kind of informed the way the compiler is going to generate the code, and you will get incorrect answers. So this little program. Are you okay, Mia?
You can make your code as unreliable as you can make your ClojureScript as unreliable as JavaScript.
Yes,
you're doing great work there, Mike.
So this little thing right here, it basically says.
Okay, so this is bad.
Now I've lost my train of thought. I don't know what I was going to say. So this little thing here, it's a type hint that actually is, it makes it so that this thing here is an incorrect program. The behavior is now undefined because we're not passing in a value that's a Boolean value.
Yeah.
But what? So you had, okay, so going back, underwinding
going
the stack
back to what
bit.
David was talking about, I guess what you're saying
exactly.
is you want to be able to check it on the way in. Yeah.
So here's what David was suggesting. If you do this, right, and then right, as S, we get Clojure spec going. What did I do wrong? What did I type wrong? I don't see what's wrong.
Clojure alpha spec, maybe?
Yes, thank you. God damn it. All right. Okay, so now the point is
everything's alpha, remember?
Okay. So what is it? X.
Whoops, Boolean, Mike. Yeah.
Boolean. Okay. So now we've spec'd foo, right? So now that we have a spec saying that the first argument to foo is a Boolean value, right? If you've done this, it's basically, we've provided another way to say that the argument to X is a Boolean value. If you've done this, then why not treat it as if you had written it this way? So effectively, the one advantage you would get from having written this spec is that you effectively get compiler optimizations as a result, and type hinting essentially.
Right.
Gotcha. Without compromising the integrity of your program.
Yeah. But also, if you can, then you can maybe turn on instrumentation as well. Yeah. Not all the time, obviously. But
you can.
Whereas, what happens with ClojureScript? I don't think is there any way now you can prevent foo0 going wrong? Whereas with instrumentation you can, but is there anything in ClojureScript to prevent it now?
Apart from
with instrumentation, you'll obviously get a spec error, but
let's see. The old school way would be like with assert, right?
Yeah. No, but I mean, as it stands, though, forgetting unless you set assert values and then somehow the assert thing checks it. I don't think it does.
Right.
You know it better than me.
Yeah.
So your question is, if you wrote this function like this one up here that I've highlighted, maybe?
Yeah.
And you want to just like somehow ensure that only Booleans are passed to that.
Well, that's really what you want now, isn't it? When you've got this type hint or this spec, that's what you want. But the problem you've got is that you're optimizing on the inside of the function, but at the call site, you're not helping because the call can still be wrong. Whereas most type systems, and spec in fact can behave like this, can tell you that you're passing the wrong value in and just stop you dead in the tracks,
Yeah. So there's an experiment that I did where effectively, and this is actually what led to David suggesting this other way of using specs. I had done an experiment where it kind of looked like this. If you did, let's see, if you did foo of X and Y, right? You wrote a function that basically treated its arguments as numeric arguments. Because I've done this, X and Y have to be numeric now, because that's what the plus operator works on.
Yeah.
Therefore, these arguments are numeric, right? Yeah. And if you say like, right, if you do this in ClojureScript, you'll get a nice little warning, right? The experiment I did would make it so that if you did the same thing with foo, you would get the same warning. It would basically say foo, and it would tell you that foo expects number, right? So what I was doing was I
like the fact that plus still works.
Don't think about it.
Won't take it away. So what I had done was
don't look at it.
Don't think about it.
So you can do like you can like do.
Script is JavaScript. Ah.
Oh yeah. Oh, you're laughing about this?
It's so scary.
It's always a source of pleasure, right? The fact
This is
that
our
JavaScript.
spooky Halloween
I'm laughing
edition.
that Foo works. You know, Foo
This is
still
the
it
spooky
likes it.
Halloween edition of
Yeah.
Apropos, right? Today we'll accidentally look
Yeah.
at JavaScript. Maze your friends, perplex your enemies, add a number and a string.
Yeah, it's trick or treat night, actually, isn't it? You know. Oh man.
See, you have to, Mike, you're looking at this in the face all the time. Like that doesn't even phase you. You're like, of course A+1 is A1.
Yeah, I guess. I don't know. I mean, I don't like JavaScript. I don't know what else to say.
No, but you're
I wish
used
it
to it.
But anyway,
I would almost prefer that something else happened. Yeah.
But so the experiment you did, Mike, with the Foo now, that seems really nice, you know. So the idea was that rather than doing it through type hints, you could do the same experiment but read from the specs.
Yeah. So effectively,
why wouldn't you do it for both situations, though? I'm just thinking or is it just to leverage specs more?
Oh, okay. Well, one disadvantage of the way that I had done it was that it gets to be pretty complex. It slows down the compiler.
Right. Okay.
But you know, if you could pull it off, and it was like, you know, it almost seems like, yeah, why not? You know. So I don't know.
Maybe the point is that with spec you can address a greater range of possibilities.
Yeah. If I had to guess, like, why was David objecting to that approach in general? Probably not so much that there was something fundamentally wrong with it. I think he was, if I had to guess, he was just suggesting, well, let's just do things the spec way, do things the normal Clojure way. Right. Like try to move towards using specs for types rather than inventing like these pseudo Hindley-Milner type analysis things that try to figure out stuff. And just like, you know, maybe you could end up with both in the end, but like it certainly the first step is like, it's obvious. Like if you define a spec, then yeah, it seems like that's information that you've gone through the trouble of basically informing the compiler of effectively types without type hinting. It's like, yeah, maybe you can leverage that then.
What you call the Hickey-Miller type system.
Oh yeah.
Mike, is there a list of available valid type tags for the new CLJS version? We've got a request for CLJ Condo.
So, okay. Yeah. I don't think there is a list anywhere that like enumerates all of them. There are certain ones that you can kind of glean by looking at the compiler and seeing like, oh, you know, it understands string and Boolean, and things like that. There's a talk that I gave that talked about a few of them. So there's only a handful of ones that the compiler does anything with, right? That it like reacts to and then generates different code based on this. But beyond that, like the set of types is kind of a little bit open-ended because you can have records that you can like give your own name to, and then they can kind of have their own types that can be hinted. That is actually one of the things that's going to be in the new compiler is if you it's just another type optimization. If you do a def record, foo, A and B, you have some fields in it, right? And then you make an instance of that. And then you access it like this. If you try to pull A out of there, right? What it'll do is the code that gets generated will look pretty much like this, right? If I could show you the code that gets generated for this, it's actually a lot more complicated than the code that gets generated for that. This ends up looking like the thing.a. It's as simple as it could be in JavaScript. It's really fast. It's like orders of magnitude faster than this construct up here. So the thing that happens there is that it sees that the type that you're passing into this, you're invoking it with a keyword. It sees that the type that you're passing in is of type foo, and it knows that it's a record, and then it will effectively take that thing and convert it to that thing, and it'll be much faster. You'll get that for free. But the reason I was pointing this out is that's kind of an example where the set of type hints is open-ended. You could have one for each record you make up, right?
Yeah.
So, but I wouldn't get too hung up on this stuff. I mean, it's kind of cool and fascinating, but it's all down in the weeds, right? I want to argue that you can just ignore it and your code will just run faster. But of course it does matter, right? We're all programmers. We want to know how the machine works and how the gears turn.
Yeah.
And
I think what Mikhail is interested in is, from a linter perspective, is just, can you give a little hint to say, I know this is going to be a runtime error. There's some things you just can't tell. But
okay.
If there's a sort of prescribed list of things where, you know there's going to be some issues like this one here, where you generate these warnings.
No, so Mikhail is in the same business that Colin Fleming's in terms of doing static analysis on your code, just and saying, hey, your code that you wrote, it's like statically analyzing your code and telling you something about it, even though the compiler's not telling you about it. That's great. Yeah. I could see the desire to understand like all that kind of stuff. Even if the compiler is not implementing some of these things, like CLJ Condo could help you. They could see things that you wrote that are incorrect, and it can even do some analysis that may be expensive to do that the compiler may not be willing to do. Right.
Right.
But you'd still like to turn it on at least and have CLJ Condo tell you.
Yeah. Okay, the one thing before we go off, because I think we're I don't know how we're doing for time actually.
It's getting close to an hour. Yeah.
Getting close to an hour. So just a 2-minute before we go off is I want to show this. I think we've announced it before, but I want to show it a little bit here. Is this replete REPL? So
replete.
Share this screen.
Woo.
Again, I don't know if you can see that, because I can't see it, but
I can't
share
see
screen.
it now.
Share screen.
All right.
Okay, I can see it. Yeah.
Okay.
I see a REPL.
Yeah. So it's this REPL.replete-web.io, and the idea is that it's like a self-hosted Clojure script REPL. So you should be able to say, doc. So let's say doc subs actually, since we've had that earlier on. It supports par-info. So it's basically Mike's code that I sort of amended a little bit to run.
A little bit.
Yeah, okay, a little bit. Okay.
That's all cool.
All the bugs are my fault. All the good stuff is your fault. That's for sure. But yeah, it's been a bit of a fun job to make it all run inside of the browser.
Yeah, Ray basically made it support prepl, right? That was a big part he did.
Yeah, that's right. Yeah. So I mean, it's the sort of thing that I don't know, you never really get the value of it or the benefit of it as a user, but from a programming perspective, it made things a lot easier. Because you can deal with the output more straightforwardly. I think. Because the nice thing about prepl is it actually gets rid of state, or it gets rid of a lot of state. Whereas, if you're doing the REPL, then obviously the REPL is quite a stateful thing, or in theory it could be, but prepl sort of removes a lot of that state, which is very nice.
That's very nice. And could we share this? Is this like the kind of thing that we could all work on, or?
Not yet, but that's my next trick. Okay, is we want to like make this like the Reptile was, but the nice thing about this is that I'm working on it at the well, not at this very moment, but I'm working on it as we, in the background. And the nice thing about this is that all the evaluation is local. So in the past, in the Reptile, it was all the evaluation was on the back end somewhere. But I decided that the security risks of that were just too hard to get my head around. So we'll just do this instead, and then all you end up doing is just essentially sharing strings around, just bits of text, and you can evaluate them as you wish. So that's the idea anyway. We'll see how that works out, but this is available right now. I mean, people can just go to the Replete-web, or in fact, you can go to Replete. Is it replete.org, Mike? Or Replete?
I can't remember.
Let's have a look.
I think it's replete-repl.org. No?
Yeah,
yeah,
there we go.
Cool.
So you can try it online. You can go to the App Store and get it on Google, and also there's a macOS version of it as well. Maybe
So
one of these days.
joined the Replete family. Yes.
Very
Yes, that's right,
exciting.
yeah.
Oh, I'm in it right now.
Ooh.
Oh, I've jumped into a REPL.
Hey, Mia, you know what we can do? We can share your
What?
screen.
But it's the same, so.
Yeah, no, but it's just like you've never shared your screen before, so it's like
It's going to
just
break
for the lols,
computer.
really, Go forget it. All right, it's the same, yeah. Bum. Okay, good. Well, that was really it. I mean, I think I'll put it on the comments in the YouTube or something later on. I'll stop sharing the screen now. Basically, if you want to try it out on the mobile or on Mac or on the web, it's totally doable, and should be good fun.
And if you don't like it, you can yell at the Twitter account and Ray will see it.
Oh man,
Don't upset
true.
Ray. Yeah.
Please be nice.
That's true. Okay, well that's it. That's it for. I mean, we spun out type-ins quite a lot there. That was quite good. I didn't know.
Yeah, don't get me
that was
started
really
on that
cool. I
stuff.
really enjoyed that.
I'm sorry.
That was not where I was expecting. Not what I was expecting to do today, but I like it.
This is the nice thing about this show. I think is we just go where the mood takes us. So that's good.
I apologize. Yeah, we didn't come to this language for types, and that's what we ended up talking about.
They're nice.
Yeah.
Yeah.
They're nice if they get out of your way. If you don't see them.
Yes. Yeah.
Okay, Mia, are you going to do the Eric ending now?
What does he normally say?
I don't know what he says. I think I
I
always
think
sleep.
he's.
Thumbs
Oh,
up and
God, yeah, you do. I think he says like subscribe and like and share it on the Twitters and stuff like that, and ring the bell,
right.
and so go for it. Okay.
All right. Thank you, everyone, for joining us today on Apropos. If you liked our cast, please feel free to click that little thumbs up button. You can also click that big red subscribe button. Remember to like us and follow us on Twitter, and have a great week, 2 weeks. Until next time, we are Apropos.
Pretty good. All right.